Hello, this is Akshay with another video here, and today's video is focusing on the term resistance. So today we are going to understand what resistance is all about. We will understand what's cause behind the worth of resistance, and finally we will understand what is the unit of resistance. So firstly, let us understand the term resistance. In the previous video, we have just understood Burke's Ohm's law, and the conclusion we have drawn in that very Ohm's law is very simple one, and that conclusion was that is, yes, there is a direct kind of a relationship existing between the current flowing through a conductor and the potential difference acting across the ends of a conductor. Let it be a conductor, and this is the potential difference. So the current flowing from one end to the another end through the conductor is directly proportional to the potential difference acting across the ends of this very conductor. In other words, we can say that it is the potential difference which makes the current to flow through the conductor. As we have learnt in that very video, that is, yes, current can't travel on its own. The charge can't travel on its own. They require a motivation. They require a kind of you can say a force which nudges them in the forward direction so that the current or charge can flow through that very conductor. So it is in need of work to be done on that very charge so that it can be made to move from one terminal to the another terminal. And that agency we have talked about, the motivation we have talked about, is nothing but it was at that time potential difference. So it means it is the potential difference which makes the current I to flow through a conductor. So it means that potential difference is making the charge to flow. But remember, the journey of charge under the action of potential difference is never ever trouble free. Charge जो चलता है कंडक्टर में से under the action of potential difference, it's never ever gonna be obstruction free. It's always hindered. It's always obstructed. It's always, you can say, that is resisted. As the charge flows through a conductor, the motion of charge, the flow of electric current, in other words, you can say that is the flow of electric current, is being opposed by the conductor there. So don't think that is just the journey of charge under the action of potential difference, or the journey of electric current, or the flow of electric current under the action of potential difference is trouble free. No, it is being obstructed by the conductor there. It is being opposed. The flow of electric current is being opposed by the conductor. It is being hindered by the conductor. It is being resisted by the conductor. Or in other words, you can say that is, yes, there is always a hindrance to the flow of electric current in a given conductor. And the name of that very hindrance, the name of that very obstruction, the name of that very interruption is known as resistance. That is called resistance. So firstly, we are going to focus on the term, the meaning of resistance here. So resistance, it is to resist. To resist, it is a simple meaning, that is to resist. You can say that is to hinder, to obstruct, to oppose. And here it is, to oppose, to resist flow of electric current. Flow of electric current. So simply speaking, the name is suggesting itself that is resistance is nothing but it is something, or it is a name of that very physical quantity which opposes the flow of electric current through a conductor. इसका मतलब ये हुआ कि जो कंडक्टर जो है, ये जो है वो जब इसमें से करंट चलने लगता है तो कंडक्टर जो है उसके मोशन को, उसके फ्लो को oppose karta hai, and that very opposing force which is being offered by the conductor to the flow of electric current, that very opposing force is named as resistance, and it is denoted by R. So remember one more thing here, that is, what is the friction in mechanics? resistance in electricity. Both are same. You may say that is both are the cousin in different territories. You can say in mechanics we do say friction. That opposing force is called friction, and in electricity we named it as resistance. So if you know what is friction, then it is easiest to understand what is resistance here. Let me take you to some to a mechanics over there, where we are gonna just take a very simple example of elementary science there. Here it is. Let it be a ground, and it is a ball, and you are applying a force on this very ball. What's gonna happen? Yeah, this ball will keep rolling under the action of applied force, in the direction of applied force as well. And what is happening? Look at keep your eyes fixed on this very moving ball or rolling ball. After a while, you will notice that ball will come to a grinding halt. It will come to a rest. Here it is. Velocity becomes zero. That's why it has stopped over here. Now, what is happening over there? Ball was moving, and thereafter it comes to rest. We have learnt in Newton's first law of motion, which also explains inertia. That law states that any body which is in motion will tend to stay in that very state of motion, or any body which is at rest will tend to stay at that very state of rest, unless and until it is being acted upon by an external force to change that very state. मीन्स कि अगर कोई बॉडी चल रही है तो वो चलती ही रहेगी, या फिर अगर कोई बॉडी रुकी हुई है तो वो रुकी ही रहेगी, अनलेस एंटिल, तब तक जब तक कोई बाहर से कोई ऐसी फोर्स ना लगे उसकी अवस्था को चेंज करने के लिए। और वही बात यहां पर हम देख रहे हैं कि बॉल चल रही थी, फोर्स लगाई हमने, बॉल चल रही थी, तो इसको चलते रहना चाहिए था। ये क्यों रुक गई यहां पर? इसका मतलब ये क्यों इसकी स्टेट चेंज होगी? बिकॉज देयर इज एन एक्सटर्नल फोर्स acting on this very ball, which is opposing the motion of that very ball, and that's why that opposing force has brought this moving ball to rest. And the name of that very opposing force is nothing but it is friction. So remember, this needs to act in this very direction. There you are. This is the direction of motion. And this is the direction of force. Direction of force. It is acting in the direction opposite to the direction of motion, and that's why it has brought it to grinding halt. इसलिए इस बॉल को जो है वो यहां पर रोक दिया गया। क्यों? क्योंकि ये अपोज कर रही थी, इसके मोशन को क्या किया जा रहा था? इसके द्वारा अपोज किया जा रहा था। That opposing force is called friction. Same is here. When the current or the electrons begin to move, ये कंडक्टर ले रखा है हमने, इसको हमने जोड़ दिया यहां पर पोटेंशियल डिफरेंस V के साथ वोल्टेज जो अप्लाई कर दी है। जैसे हमने वोल्टेज अप्लाई कर दी, व्हाट इज गोना हैपन? दिस इज द नेगेटिव टर्मिनल ऑफ द बैटरी, इलेक्ट्रॉन्स विल बिगिन टू मूव हियर, electrons will begin to move. So you may say that is, yes, this is the direction of flow of electrons, then this is going to be the direction of electric current I, because the direction of electric current is opposite to the direction of flow of electrons. So under the action of potential difference, electrons begin to move from one terminal to another terminal in the external circuit. So during their journey, they are going to be greeted with obstruction. There comes the obstruction. There comes the, you can say that is opposition to the flow of electron. As the case over here, you have kept the ball rolling, but it came to a grinding halt after some time, because of the reason that there was an opposing force which opposes the motion of that very wall. And that opposing force was named as friction. And same is here. As the electron begin to flow through the conductor, its motion is being opposed by the, you can say, the multiple collisions. It is the result. You can say that is the multiple collisions going on over there. It is being opposed by the atoms and ions present in that very conductor. The ions are there, atoms are over there, even electrons and electrons are colliding with one another when they begin to move. And during those multiple collisions, वो जो टकराव होते हैं, इलेक्ट्रॉन्स का इलेक्ट्रॉन्स के साथ भिड़ जाना, इलेक्ट्रॉन्स का एटम्स के साथ जो है वो टक्कर मारना, इलेक्ट्रॉन्स का आयंस के साथ जो है वो टक्कर मारना, ड्यूरिंग दीज मल्टीपल कोलिजन्स, ड्यूरिंग दीज काउंटलेस कोलिजन्स, द मोशन, द फ्लो ऑफ इलेक्ट्रॉन्स गॉट हिंडर्ड। जो फ्लो है, जो बहाव है इलेक्ट्रॉन्स का, उसमें बाधा पड़ती है, उसमें हिंड्रेंस आती है, एंड दैट वेरी हिंड्रेंस is known as the resistance, as the case over here, that is it is opposing force is called friction। और ये friction कहां से जन्म ले रहा है? This is the irregularities we have just noticed over the surface of the ground, even the body which is rolling on that very surface of the ground, and that is giving birth to the opposing force called friction. Same is here. The resistance is taking birth from nowhere, but right from this very conductor. That is where the birth of resistance is gonna be take place. And that resistance has got a very special property. And what's that property? Its property is to oppose the flow of electron. And as a result of this, that very opposition to the flow of electron or to the flow of electric current is known as the resistance. So here this opposing force is called friction in mechanics, and here the opposing force which obstructed or which is hindering or which is opposing or which is resisting the flow of electric current through the conductor, that very opposing force is known as the resistance. So we have just understood here the reason of you can say the friction here, that is it is coming from the irregularities existing over the ground there, and that's where it has taken birth. And similarly we are going to understand the you can say the origin, we are going to understand where that resistance has come from in that very conductor very shortly, though I have just put a bit light on the origin of the you can say resistance being offered by the conductor to the flow of electric current. But anyway, I am going to come over here after a while. But here we are very much over here, that is the resistance, to resist, to hinder, to obstruct, to oppose the flow of electric current through the conductor. So that is the definition here. That is, yes, that is the resistance of a conductor is a property of that very conductor by virtue of which it opposes, it resists, it hinder, it obstruct, it you can say that it resist the flow of electric current. Is that very property is known as the resistance of that very conductor. That is the property by virtue of which a conductor opposes the flow of electric current is known as the resistance of that very conductor. की वो गुण, वो विशेषता कंडक्टर की जिसके चलते वो करंट के बहाव को अपोज करता है, उसमें बाधा डालता है, उसको बाधित करता है, उस प्रॉपर्टी को नाम दिया जाता है रेजिस्टेंस का. दैट प्रॉपर्टी ऑफ अ कंडक्टर इज नोन एज द रेजिस्टेंस एंड इट इज डिनोटेड बाय आर. हियर इट इज डिनोटेड बाय आर. नाउ दैट इज द डेफिनेशन ऑफ रेजिस्टेंस. What is the cause? And thereafter we are going to come across the numerical you can say definition of that very resistance. But firstly we are going to discuss what is the cause of resistance. So cause, I have just put some light on the cause of resistance, that is here and why the resistance has taken birth. So there is a conductor. When the charge begins to flow through the conductor, its motion is being opposed by the, you can say that is atoms and ions present in that very conductor. So it means it is the you can say a nature of that very conductor. You can say that is it is the you can say conglomeration of atoms and ions present in that very conductor, which is collectively responsible for the obstruction, for the hindrance, for the opposition to the flow of electric current through the conductor. तो जैसे ही जो है वो इलेक्ट्रॉन जो है वो चलते हैं, I have told you that is the journey of charge from one terminal to another terminal is never ever gonna be trouble free. So because as we are moving on the ground, remember our motion is continuously being opposed, and that opposing force is known as the friction. So there is a tussle going on between the muscular energy of our legs and the opposing force coming from the surface of ground called friction. But if your muscular energy is more than the frictional force, then you will keep moving. So same is happening over here. The two kind of you can say forces are at play here. This is the potential difference encourages the electrons to surge ahead. पोटेंशियल डिफरेंस इलेक्ट्रॉन्स को इंकरेजमेंट देता है, मोटिवेशन देता है कि वो आगे चले. बट रेजिस्टेंस डीमोटिवेट द फ्लो ऑफ इलेक्ट्रॉन्स. रेजिस्टेंस बाधा डालती है, पोटेंशियल डिफरेंस आगे धकेलता है और रेजिस्टेंस जो है वो बाधा डालती है. इलेक्ट्रॉन्स या चार्ज जो चलेंगे उनकी जो रेट है, उनकी जो स्पीड जो है, उनका जो बहाव जो है, उसकी दर जो होगी, उसकी जो स्पीड जो होगी, रेट जो होगा, वो इन्हीं दो अपोजिंग फोर्सेस के जो है वो कलेक्टिव नतीजे के ऊपर टिकेगा. Which are those two forces? One is the potential difference, which is forcing the electrons to get through the conductor from one terminal to the another terminal, and this is the encouragement being provided by the potential difference to the flow of electrons or to the electrons. But at the same time, what the conductor is going to do? The conductor is going to discourage the flow of electrons. Conductor is going to oppose the flow of electron, and that discouragement is known as resistance. So the rate of flow of electrons through the conductor depends upon the collective effect of both the quantities, that is the potential difference, which is going to encourage or motivate the electrons to go ahead, and the resistance of the conductor, which is going to discourage or demotivate the flow of electrons. That's what its quality is. So the you can say rate of flow of electrons through the conductor depends upon the collective result or collective effect of both the opposing forces, that is potential difference acting across the ends of a conductor and the resistance being offered by the conductor to the flow of electrons or to the flow of electric current. And the collective impact or effect of these two opposing forces is gonna determine the rate of flow of electric current or rate of flow of, you can say, electrons through that very conductor. So that's what the resistance is all about. So now we are gonna discuss what is the cause. As the potential difference encourages the electrons to move through the, you can say, conductor having resistance R, then what's going to happen? As it begins to move through this very conductor, what is going to happen under the action of potential difference? Firstly, electrons are going to collide with one another. There are going to be multiple collisions. Electron आपस में टक्कर मारेंगे. And that is obstruction. That is hindrance to the path of electrons, to the flow of electrons. A. B. Electrons are going to collide with the ions present over here in that very conductor. Electrons are going to collide with the atoms present in that very conductor. Due to these countless or multiple collisions, the motion, the flow of electrons or electric current is being opposed by that very conductor. And that's the reason these multiple collisions between electrons, electron atoms, electron ions, these multiple collisions between electron atoms, electron ions resulted in, you can say, that is obstruction, resulted in hindrance, resulted in a kind of opposition to the flow of electric current, and that very opposition is known as the resistance of that very conductor. So the reason or the cause behind the birth of resistance is the obstruction, is the opposition being offered to the flow of electric current by virtue of the multiple collisions going on between electrons, electron atoms, electron ions present in that very conductor, and that's what causes the resistance to take birth in that very conductor. So that's the, you can say, a reason or a cause behind the birth of resistance which is being offered by the conductor to the flow of electric current through it. Now we are going to understand the numerical definition of the resistance. Resistance, as I have told you, it is denoted by R. And in order to understand the numerical resistance, we need not to go far away. We have understood in the case of Ohm's law, which states that is, yes, I is directly proportional to V. And as we have moved further, we have seen and we have reached at this very end, that is V is equal to IR. And this is according to Ohm's law. V is equal to IR. Here it is. This is resistance. This is electric current I, and this is the potential difference or voltage. Or R is equal to, I goes over here, and it is V upon I. Therefore, you can say here that is resistance is equal to potential difference acting across the ends of a conductor divided by the current flowing through the conductor. This is, here it is the definition. So numerically, we can say that is the resistance of a conductor, that is R, is defined as the ratio. This is the ratio, is defined as the ratio between potential difference acting across the ends of a conductor, ratio between the potential difference acting across the ends of a conductor to the current flowing through the conductor. So that's the ratio existing between the potential difference to the current flowing through the conductor is known as the resistance. So this resistance is nothing but the ratio between potential difference to the electric current. So how much potential difference you are gonna use over here in order to make the current I to move from one terminal to another terminal through a resistance R is known as, that is, yes, this is going to determine the, you can say that is going to be put up, is gonna be put up in this way, that is resistance is equal to potential difference upon current. That is the ratio between potential difference and current is known as the resistance of that very conductor. So that is the mathematical, you can say, definition or numerical definition for the resistance of a conductor, which is a ratio existing between the potential difference acting across the ends of a conductor to the current flowing through that very conductor. That's the definition here. Now we are going to come across the unit. The SI unit of resistance is Ohm. Resistance unit is Ohm, and it is represented by Greek letter, that is omega. Here it is called omega. So that is the SI unit of resistance, that is Ohm, and it is represented by Greek letter that is called omega. And earlier we know that is the unit of potential difference. Unit is volt, and it is denoted by V. And the unit of SI unit of electric current ampere, and it is denoted by A. So in case of unit, we can write it as, in case of unit, in place of resistance, it is going to be Ohm. Here it is, Ohm is equal to, in case of potential difference, the unit of potential difference is volt. Here comes volt. And SI unit of electric current is ampere, or Ohm is equal to volt. Here it is, Ohm is equal to volt upon ampere. So that's the unit, and we have understood what is Ohm equals to. It is equal to volt upon ampere. And now we are going to understand what is 1 ohm resistance. And in order to understand 1 ohm resistance, we will put, as we know, ohm is equal to V upon A. That's what we have just found over here, that is ohm is equal to V upon A. Now we are going to apply 1 ohm is equal to 1V upon 1A. Now the resistance of a conductor is said to be 1 ohm when 1 ampere current flows through a conductor under the action of 1 volt potential difference. This is 1 volt. It is current is 1 ampere and this is 1 ohm. So the resistance of a conductor is said to be 1 ohm when 1 ampere current flows through a conductor under the action of 1 volt potential difference acting across the ends of a conductor. Means कि किसी भी कंडक्टर की रेजिस्टेंस 1 ओम तब कहलाई जाएगी जब उस रेजिस्टर से या उस कंडक्टर से 1 एम्पियर करंट चलेगा, और करंट 1 एम्पियर चलेगा तो वो बिना जो है वो अपने आप नहीं चलेगा, बल्कि अंडर द एक्शन ऑफ पोटेंशियल डिफरेंस वो करंट चलेगा. जब 1 एम्पियर करंट जो है वो 1 वोल्ट पोटेंशियल डिफरेंस के प्रभाव के तले चलेगा, तब वो कंडक्टर उसकी रेजिस्टेंस जो कहलाई जाएगी, देन दैट वेरी रेजिस्टेंस इज गोइंग टू बी नोन एज 1 ohm. So that's it here as far as the definition of 1 ohm resistance is concerned. That is, the resistance of a conductor is said to be 1 ohm when 1 ampere current flows through it under the action of 1 volt potential difference. That's it here as far as the unit of resistance is concerned.